As I told you about the uniform acceleration, we are going to discuss about 4 formulas. Well, now the second one, velocity with constant uniform acceleration. So this is the second formula. It is the v final equal v initial plus acceleration multiplied by the time. This is the final velocity. V initial, that's equal initial velocity. A is the here acceleration. Delta t is the time. And we have a third formula, displacement with constant uniform acceleration. Displacement with uniform acceleration. So here we are going to calculate the displacement, which is delta x. Delta x is the displacement. That's equal v initial velocity multiplied by the time plus half is the coefficient, a is the acceleration, delta t squared. Delta t is the time. In the questions, I'm gonna use these formulas. I hope you will understand it when I solve the question better. Now I'm gonna solve the problem about the second and the third formula. It is the sample problem 1D. It's all about velocity and the displacement with uniform acceleration. Let's read the problem and try to understand it. A plane starting at rest. So it says the plane starting at rest. That means what? Initial velocity of the plane is 0. At the one end of a runway, that means you know what's the meaning of runway, undergoes a uniform acceleration. So this word must be your keyword, uniform acceleration, which is 4.8 meter per second square. So our acceleration here 4.8 meter per second squared for 15 seconds before takeoff. So delta t is 15 seconds here. What is its speed at takeoff? So it's asking, that means what is v final? And we have another question, that means second question, how long must the runway be for the plane able to take off? So also it's asking delta x. So what is the delta x? So here in this problem we have two questions. We have 3 givens and 2 unknowns, we can say. And if you remember the previous formulas, you can solve these questions easily. But before it, let's understand the question. Let's say this is the airplane, like this. We have plane here. That plane's initial velocity is 0. So as you know, this plane speeding out up on the land, and then it take off. It start flying, but on the ground it's moving. So here the first question is the v final at this point. What is the takeoff speed, we can say, takeoff velocity at this point? And the second question, what is the distance from its initial position to final position on the land? So it is delta x. Let's change the color of the marker and let's continue. First one, v final. How can we find v final? If you go back to previous page, we have formula, second formula and the third formula. Second formula is about v final, third formula is about delta x. So what is the v final? V final equal v initial plus acceleration multiplied by time. So the question says what's v final? We can substitute directly given what's the initial velocity. Initial velocity is 0 plus acceleration is 4.8 multiplied by the time. What is the time given? 15 seconds. So final velocity gonna be 72 meter per second. Unit of the velocity is meter per second. And we solve first question. First one is done. Now second question. What is the second question? What is the delta x? And which formula we are going to use? Third formula. Delta x equal v initial times delta t plus half a t squared. And what's the initial velocity? Let's change the color of the pen again. What's the initial velocity? Initial velocity is 0. So this part of the equation gonna be 0. So delta x will be equal half a t squared. So it will be equal half. What is the acceleration? Acceleration is 4.8 multiplied by t squared, square of the time. Time is 15. So it will be square of the 15. So delta x is gonna be 540 meter. So this is the answer of the second question. Now we reach the practice 1D. There are 4 questions. I will solve some of them. I hope you are going to understand. In this question it says a car with an initial speed of 23.7 km per hour accelerates a uniform rate of 0.92 meter per second squared for 3.6 seconds. Find the speed and the displacement for the car. So it's asking what is the speed and what is the displacement. That means what is the v and what is the x. And here let's write the givens. V initial equal 23.7 km per hour, and another given acceleration which is 0.92 meters per second square, and the time is given which is 3.6 seconds. Acceleration unit meter per second square, unit of the time second. So I have to convert initial velocity into meter per second, and initial velocity is given kilometer per hour. So 23.7 times 1000 meter over 3600 seconds. So it's gonna be 6.58 meter per second. And at the first case it's asking final speed, that means v final, and we have formula about the v final, which is v final equal v initial plus acceleration multiplied by the time. And it's asking x. Formula of the x is equal v initial times t plus half a t squared. So for the v final formula, v final equal v initial plus a multiplied by the time, and initial velocity is 6.58 meter per second plus acceleration is 0.92 multiplied by the time, which is 3.6. So the final answer is gonna be 9.892 meter per second. And the formula of the x is v initial times t plus half a t squared. Initial velocity is 6.58 multiplied by the time, which is 3.6 in the brackets, plus half. Acceleration is 0.92 multiplication, and the time is 3.6 squared. Then x gonna be 6.58 times 3.6 is the 23.688 plus 5.961, and then finally our answer gonna be 29.65 meter. Thanks for listening. A car starts from rest. If the car or an object starts from rest, that means initial velocity must be 0 and travel 5 seconds with a uniform acceleration. That means time is 5 seconds, and the acceleration given negative 1.5 meter per second square. And it's asking what is the final velocity of the car. That means what's the v final. Then it says how far does the car travel in this time interval. That means it is saying what is the x. Final velocity formula is equal to v initial plus a multiplied by the time. So it's equal, initial velocity is 0, so this will be 0. Acceleration is negative 1.5 multiplied by the time, which is 5. So it's gonna be negative 7.5 meter per second. And then it's asking what is the x. And the formula of the x is v initial times t plus half a t squared. And initial velocity is 0, so this part will be 0. So the formula in this case, it will be half a t squared only. And if you substitute the given, half times a is negative 1.5 multiplied by the time is 5 squared. So finally x gonna be negative 18.75 meters. Thanks for listening. Now we reach the fourth formula about the uniform acceleration. That is, this is the fourth formula. V final square equal V initial square plus 2a delta x. V final is final velocity, V initial is initial velocity, 2 is the here coefficient, a is the acceleration, delta x is the displacement. Now you know here any letters meaning. So this problem will be about this formula. And let's read the problem and try to understand it. A woman pushing a stroller starts from the rest. When it says start from the rest, it means to us initial velocity is 0. Uniformly accelerating. So we reach again our keyword, uniform acceleration. When you reach uniform acceleration, word, when you hear uniform acceleration, when you read uniform acceleration, you are going to use one of those four formulas. This is important. At the rate 0.5 meter per second square, so this is the acceleration, which is 0.5 meter per second square. What is the velocity of the stroller after it has traveled 4.75 meter? So delta x is given 4.75 meter. And it says what is the velocity of the stroller after. So it means it's asking to us what is the final velocity of the stroller. So here, as you see in this question, it's not like a previous question. What is the difference here? There is no any time given in this question. And in this formula, we don't need any time because this formula is time independent. V final square equal V initial square plus 2a delta x. Let's change the color of the pen. And what is the initial velocity? Initial velocity is 0, so this will be 0. And the question says what's the V final? We can use formula directly. V final square equal 2 times, what is the acceleration? 0.5 multiply by delta x. Delta x is 4.75. To calculate the V final, we have to take root of the both sides. Root and the square can cancel each other. So V final will be 2 and 0.5 will be 1. And it will be root of the 4.75. So result will be 2.18. What's the unit of velocity? Meter per second. Now guys, we reached the practice 1E. I'm gonna solve some of them. I hope you are going to understand them. In this question it says, a car traveling initially 7 meters per second accelerates uniformly at the rate of 0.8 meter per second square for a distance of 245 meters. Find the velocity of the car at the end of the acceleration. So it's asking here final velocity, its velocity after it's accelerate for 125 meters, its velocity after it's accelerate 67 meters. And the given V initial is 7, acceleration is 0.8, and the x is 245 meters. And the formula about this, we have a time independent formula. V final square equal V initial square plus 2a x. And for the a, if we use this formula, V final square equal V initial square plus 2a x. And the V initial is 7, so 7 squared plus 2 times a is the 0.8 times x is 245. So V final gonna be 49 plus 392, and then V final square gonna be 49 plus 392, so it will be 441. Then if you take the square root of the both sides, we will find the V final, and the V final is equal 21 meter per second. Now I'm gonna solve B. At the B, I will use same formula, but for the B, x is equal 125. V final square equal V initial square plus 2a x, and the V initial again 7 square plus 2 times a is the 0.8, and now x is the 125, and the V final square gonna be 49 plus 200, so V final square gonna be 249. If you take the square root of the both sides. V final gonna be 15.78 meter per second. Now I'm gonna solve the C. At the C, x equals 67 meter, and then I will use the same formula. V final square equal V initial square plus 2ax, and the V final square equal initial again 7 square plus 2 times 0.8 times 67, and the final square will be 49 plus 107.2. Then the final square gonna be 156.2. If you take the square root of the both sides, we will find the V final, and the V final is equal 12.5 meter per second. Thanks for listening. In this question, it says a car accelerates uniformly in a straight line from rest. It says from rest, that means initial velocity is 0 at the rate of 2.3 meter per second square. It is the acceleration. What is the speed of the car after it has traveled 55 meter? Let's write the given first. We have acceleration, which is 2.3, and we have initial velocity, which is 0, and then we have x, which is 55 meter. And the choice of A, it says what speed of the car after it has traveled 55 meter. The formula about it, V final square equal V initial square plus 2ax, and the initial velocity is 0, so we will use the formula as a V final square equals 2ax, and the 2 times a is the 2.3 times x is the 55, and V final square gonna be 253. If you take the root of the both sides, V final gonna be 15.9 meter per second. And at the B, it says how long does it take the car travel 55 meter. So what does it mean, how long does it take the car travel 55 meter? It's asking time. So to calculate time, I have another formula. X equals half V initial plus V final multiplied by the time. And x is given, initial velocity is 0, final velocity I calculated here, and only missing is the t. So instead of x, 55 equal half times V final, which is 15.9 multiplied by the t. And if I send 2 here, it will be 110 equal 15.9 t. So if you divide it by both sides, 15.9 t gonna be finally 6.9 seconds. Thanks for listening. In this question, it says a certain car is capable of accelerating at a uniform rate of 0.85 meter per second square. What is the magnitude of the car's displacement as it accelerates uniformly from speed of 83 km per hour to one of 94 km per hour? So in this question, it's asking what is the x. So we are going to calculate x first of all, and let's write the givens. We have acceleration, which is 0.85 meter per second square, and we have speed, initial speed is 83 km per hour, and final speed 94 kilometer per hour. So in this question, initial and final speed are given kilometer per hour, so I have to convert them meter per second. V initial is 83 times, instead of 1 kilometer, 1000 meters, over, instead of hour we have to put seconds, 3600 seconds, so it's gonna be 23.05 meter per second. And we will do same steps. I will convert it meter per second. 94 times 1000 over 3600, so it's gonna be 26.11 meter per second. And these are the givens. And now I'm going to use formula to calculate the x, which is v final square equal v initial square plus 2ax. And the final velocity 26.11 square equal initial velocity 23.05 square plus 2 times a is 0.85 times x, and 26.11 square is equal 681.79, and 23.05 square equal 531.55, plus 2 times 0.85 is 1.7x. I will send 531.55 to left side. Result will be 150.24, which is equal 1.7x. So I will divide both sides 1.7 to calculate x. So x gonna be equal 88.37 meters. Thanks for listening.